Hello and welcome to the final question of this A-Level 2023 Paper 3, Pure Mechanics. I really hope you've enjoyed them so far. If you have, don't forget to like, comment and subscribe. So this one's about pulleys and we've got two particles connected by a pulley. So let's give it a go. Now what I do with these is as soon as I read something in the question, I start to draw it on the diagram. So the diagram shows a small block B of mass 2 kilograms, which means we're going to have the weight of B acting downwards. And similarly for P of 4 kilograms. Now remember, weight acts vertically downwards, doesn't it? The string is taut and passes over a small smooth pulley. The particle can move on the inclined plane, which is rough. Okay, and which makes an angle of 60 degrees with the horizontal. The block can move on the horizontal surface, which is also rough. So both of these surfaces are rough, which means we're going to have friction. Now, B, we're going to have some kind of reaction force. Let's call this RB. And similarly at P. Okay, the system is released from rest, and in the subsequent motion, P moves down the plane and B does not reach the pulley. This tells me which way friction is acting. So if we're accelerating this way, then friction is going to try and stop that, which means friction is working this way. Let's call this FP. There's going to also be tension in the string in these directions. And similarly then, we're going to have friction trying to stop B getting towards the pulley. So let's call this FB. Okay, I think that's everything we need. It's given that the coefficient of friction between P and the inclined plane is twice the coefficient of friction between B and the horizontal surface. So let's call the friction at B, let's call that mu B. Let's call the friction at P mu P. And we're told that this one is twice the other one. So 2 mu of B. Okay, one last thing we should do is we should resolve the weight of the particle at the angle, which means creating this triangle here. This angle is 60, which means this component here is 4g sine 60, and this component here is 4g cos 60. Determine in terms of G the tension in the string. So I'm just going to need to do all of the equations possible here. So let's start with B, because B is the easiest particle to work with. So for B, I'm first going to resolve perpendicular to the surface. So we can see that RB equals 2G. Okay, resolving parallel in the direction of acceleration, we can see that T equals FB. Okay, so that's a good start. Let's do the same thing for P. So let's resolve first perpendicularly. So we can see that RP, so the reaction force at P, is going to be equal to 4g cos 60. I've just realised I've missed something off one of these equations up here. So, in fact, that one was okay, it's this one. So we had RB is 2g. The one in the direction of acceleration, I'd easily forgotten that we've got acceleration here. So it's actually T minus FB equals 2a. Okay, now that should be better. Okay, and then in the direction of acceleration, which is down the plane, we're going to have 4g sine 60 minus T minus FP equals 4a. Okay, so those equations are looking much, much better now. All right, let's see what we can do from here. So ultimately, we need to eliminate A, and we need to eliminate everything to do with the kind of frictional bits. So let's start by working out some stuff. So let's start with the friction at B. The friction at B is going to be mu B multiplied by the reaction at B. And the reaction at B is just 2G. So FB is going to be 2G mu B. Let's do the same thing for the friction at P. So the friction at P is going to be mu P, lots of, and then the reaction is 4G cos 60. Okay. Now we know that mu P was 2 mu B, and then cos of 60 is a half, so this is just 2G. So overall we get that FP is 4G mu B. Okay, good. Right, where can we go next? Well, what we can say now, let's take a look at this equation here. And let's plug in FB. So we can see that T, take away 2G mu B, is 2A. Okay, that's good. And let's take a look also at this equation here. So we can see, well, so sine 60 is root 3 over 2. So this is 2 root 3G minus T. And then FP is minus 4G mu B. And this equals 4A. Okay, good. These are a pair of simultaneous equations now. So we need to kind of eliminate everything we can. So let's see what we can do. Well, yeah, so looking at this equation here, we can get T on its own by doing 2A plus 2G mu B. And so, actually, now I wanted to do the other one first. Okay, so I actually want to get T on its own in this one. Yeah, so T is 2G mu B plus 2A. And then if you look at what I've got over here, I've got 2 root 3G minus T equals 4G mu B plus 4A. And 4G mu B, so this part here, that's just double T. 4G mu B plus 4A. So what we can say now is that, I'll go onto another screen. 1 second. So we'll just go add slide, there we go. Okay, so what we can say now is that 2 root 3 G minus T is just equal to 2T. Okay, and that's again because this here is just the same as 2T. Right, add T to both sides and we get 2 root 3 G equals 3T. And then divide both sides by 3, we get 2 root 3 G over 3 equals T. And that is our tension in the string there. Okay, so I hope that helps for part A. Let's move on to part B. Okay. So do we need to keep any of this? I think we'll be okay. I think we'll be okay. So let's get rid of all this. If we can. And it's not letting us. That's fine. All right. So, part B. When P is moving down 2 meters per second, the string breaks. In the 0.5 seconds after the string breaks, P moves 1.9 meters down the plane. This is a suvat straight away. So clearly, when the string breaks, we've got different acceleration. So straight away, I can do a suvat, which is quite nice. You know, you wouldn't expect at this part of the paper, the last question, for the start of the question to be such a nice start. So what's happened? The strings kind of broke, and so P's falling. Okay, P's falling down the plane, and it means P and B are no longer connected. So there's no tension as well, which is quite interesting. So after the string is broke, P ends up moving 1.9 meters. So S is 1.9. We're told it's when it's moving at 2 meters per second. So U is 2. And then that takes 0.5 seconds, and we want to know A. So if you think about it, P is still going to be accelerating. So which equation is this? Well, it's S equals ut plus a half at squared. So 1.9 equals 2 lots of 0.5 plus a half a times 0.5 squared. Okay, so what do we end up with? 1.9, take away 1, times by 2, and then we're going to, I'll keep it like that for now. So this is an eighth, and this is 0. Hang on, where's my times 2 come from? Okay, yeah. This is what happens when you rush a little bit. So let's not rush. Okay, so 1.9 is 2 lots of 0.5 plus a half a times 0.5 squared. So 1.9 take away 1 is, this is an eighth, because 0.5 squared is a quarter, times a half is an eighth. So 0.9 equals a over 8, and so a is 7.2 meters per second squared. Right, this is good. So what do we need now? Well, we want to work out the deceleration of B after the string breaks, which means we need to know these coefficients of friction. So what did we say? We said that mu B, and we said that mu P is 2 lots of mu B. All right, well, when the string breaks, like I said, there's no more tension in the string, but there is still friction. What's going on with my iPad today? It's not liking it. So there is still friction here. There is still that reaction force. And there was still, this was 4G, and this was 4G cos 60. So what did we have? We had that RP was 4G cos 60, which was 2G. And so FP is mu P lots of 2G, like so. But now we've got to consider our equation. So our equation in the direction of acceleration is now 4G sine 60 minus FP equals 4A. But we know what A is now, so we can work out FP. So FP is, that's 2 root 3G minus 4A. Okay, so we'll go over to the calculator. So what did I say? 2 root 3G, 2 root 3G, so times 9.8. Minus 4 lots of, and then the acceleration I've just worked out is 7.2. So this gives me that the frictional force is 5.14. Okay, let's do one more decimal place, so 8. Okay, so let's go over to the next slide. Okay, there we go. So we've just worked out that FP is 5.148, but we also know that FP is mu P lots of, what did we say, 2G? So mu P is FP over 2G. So I'm going to divide my answer by 2 times 9.8. So 2 lots of 9.8. And this gives me 0.262, 0.2626. So let's go to 3 significant figures. So 0.263. And if I know what mu P is, I can now work out mu B. Because mu P was 2 lots of mu B. So to get mu B, I'm going to divide by 2. So divide my answer by 2, and I get 0.131. Again, to 3 significant figures. Okay, this is good now. So now that I know the coefficient of friction up at B, up here, I can now do a similar type equation. So, what did we have for B? Well, we had that the reaction at B was just 2G, the weight, and we had that the equation without tension is just going to be the friction acting this way. So it's going to be minus FB equals 2A. Okay? And minus FB is just minus this mu I've just worked out, 0.131 times by 2G. And then to get A on its own, I'm going to divide by 2. So let's see what this gives us. So multiplied by 9.8, and then times -1, and then divided by 2. So it's minus, let's see, we've got minus 1.287. So let's go to 3 significant figures. We've got minus 1.29. So that's the acceleration. So I just need to be super clear and say that the deceleration is 1.29 meters per second squared. And there we have it. We have finished this paper. That was a tough question to end on. You need to be good with your algebra, to be good with your friction, to be good with your resolving. Really hope you enjoyed. As I say, please drop a like if you have and share to your friends. See you later.